So in a perfect world, if I'm going to take, we often will model gasoline as octane. Octane would be something like C8H18, okay? And whenever I burn something, I need CO2, and it produces, to burn something, I need oxygen, that's right there, and then it produces water, carbon dioxide, and I'm just going to put an E for energy here. So this is the basic combustion equation. Hopefully you remember from chemistry. Again, it was a carbon compound plus oxygen gives CO2, water, and energy. Now, if I was going to go and, this is the maximum amount of energy you can get is if you burn and you produce only CO2. So in a perfect world, you're going to be, and this is going to be called complete combustion. All right, and for complete combustion, if I were to balance this equation, balancing the equation, remember, is every carbon, so there's 8 carbons on the left, so I have to have 8 carbons on the right. I would have 9 hydrogens, 9 times 2, 18 hydrogens on the right to balance the 18 hydrogens on the left. And then in the end, I have 25. I have 8 times 2, 16 plus 9. I have 25 oxygens. So I can either balance this with 25 halves for oxygen, which some chemistry teachers get mad at me for doing that, but since it's what's called a diatomic, that's okay. So this is the idea of complete combustion. This would give you the maximum amount of energy. So this is really what we want in combustion. However, I hate to break it to you, but the world ain't so perfect. And so we really don't get complete combustion as much as we might hope to get it. And so in this next equation, I probably should have just left this in black. I'm going to have something called incomplete combustion. So incomplete combustion means it is not producing as much energy as it could because I am producing some of this thing here called carbon monoxide. So this carbon monoxide, again, it's just CO. And so if I were to balance it, there's actually a lot of different ways I could balance this, but I'm going to just balance it where I'm going to say, I'm going to put 4 here and I'm going to put 4 here. So I have 8 carbons here and 4 and 4. I got 8 carbons over there. I'm going to put a 9 here to balance out my hydrogens because now 9 times 2, 18 and 18. And so my total oxygens, I'm going to have 4 times 2, 8 plus 9 is 17 plus 4 here. So 17 plus 4 is 21. So I'm going to do 21 halves here. So notice, once I have a carbon monoxide formed, and even if I just did 1 carbon monoxide rather than doing 4 of them, I still would not have, I would have a little bit less oxygen that was used. So whenever oxygen is a little bit lacking, incomplete combustion will occur, and incomplete combustion forms carbon monoxide. So that is from combustion processes what this idea of incomplete combustion is. Now, this is assuming a world where octane is, or gasoline is C8H18. Really, what you're going to see so often is you're going to see C8H18 again. This is saying in a perfect world. But then there's going to be maybe some nitrogen or some sulfur stuck in there too. There's going to be impurities in my gasoline. So if I add oxygen to that, I'm going to say I'm going to get CO2. I'm going to get carbon monoxide. I'm going to get my water. I'm going to get sulfur dioxide. That because any sulfur on the left side has to produce a sulfur compound, and it's usually going to be sulfur oxide. And then nitrogen oxides, often we'll say NOx, but for simplicity, I'm going to say NO2. Again, it could be NO, it could be NO2, etc. They could be, I'm for simplicity just going to say NO2. And so if I went out and I started trying to balance this, okay, it becomes much, much messier. But I'm going to just, again, this is not really the perfect formula. It's just kind of my model of a formula here. but I'm going to say I'm going to do 4 and 4 here. I got 1 SO2, I got 1 NO2 because I have 1 sulfur here and just 1 nitrogen there. And then in the end, if I were to balance out my oxygens, I have 8 and 4 is 12, and 9 is 21, 22, 23, 24, 25. So I'm going to go to my 25 halves here. And so this would be an example of really when I burn gasoline, what comes from burning gasoline. So when I burn gasoline, I'm going to get sulfur dioxide, and this is going to be from the sulfur in the gasoline. There's very little sulfur in gasoline. There's actually more sulfur in diesel fuel, and they've started making low sulfur diesel. So I'm going to say low sulfur diesel. So there's much less sulfur in there, and that was a way they've reduced the sulfur dioxide, but you still do get some sulfur dioxide emissions from like a gasoline and from a diesel. If there's some nitrogen impurities, this is going to come from the nitrogen in the gas, the nitrogen in the gasoline. All right, and that NO2 is going to be formed from that. Or remember, for any burning, you're going to take in air, and in the air is 78% nitrogen gas, 21% oxygen gas. In an engine, so I'm going to say in an engine, which is at high temperature and pressure, you're going to form NOx or NO2. So this nitrogen in the gasoline can form the NO2, or just simply having an engine can form this NO2. And then my CO comes from this incomplete combustion. And again, whether I'm burning gasoline, whether I'm burning coal, that's where my CO is going to come from. And my CO2 also comes from complete combustion. So those are all these different ways that I'm going to get all these different emissions from gasoline and the combustion of gasoline, or combustion of really any fossil fuel is really what this should be. I shouldn't just say gasoline, I should say any fossil fuel. Hope that was helpful.